Welcome friends to the online course on health, safety and environmental management. We are talking about lectures on module 1, where we are continuing to discuss on topics related to environmental management. We are trying to focus our discussions only to those issues which causes ecological disturbance to the marine aquaculture, which is essentially caused from the oil and gas industries alone. So, our focus was not actually to discourage the whole industry in terms of its exploration and production, because that is one of the lifeline of economy of every nation. We know that under the increasing demand of energy requirements for various industrial development etc., we agree and understand that hydrocarbon exploration is one of the vital part, there is no doubt on that, but however we cannot ignore certain facts and we are going to take care of them in advance before the environment start posing serious threat to the livelihood of the human being or the habitat living nearby, not necessarily only the human being, but also the marine organisms. So, we have seen the various facets of issues connected to drilling discharges, storage reservoirs, where are the issues coming up, what are the physical, chemical and biological issues related to environmental degradation, which occurs essentially from one of the process which affects it seriously, which is nothing but hydrocarbon oil exploration, production, processing and discharging. But however, all these discussions what we had so far are maybe intermittently or continuously monitored using ecological monitoring programs, which we also saw in the previous lectures, but all of them do give a warning to the society and the offshore engineers that yes, there is a serious threat posed to the environment because of this. However, there are industrial and regulatory agencies which control the limitations of these discharges both in ocean as well as in atmospheric pollution, as we saw in the previous lectures. However, if these stringent measures are followed, we will not be able to create or we will not be responsible for causing environmental degradation, essentially as a part of the important societal contributor as an offshore engineer. But under the whole issue, we have a very interesting scenario which is happening here. All these are discussions related to a scenario which are likely to happen, which are likely to exceed, which are likely to overcome the threshold values. So, any scenario which is likely to exceed or overcome, which can pose threat, is what we call as hazard. So, hazard actually is a scenario. Please understand, we are not saying that the hydrocarbon exploration, production, processing and discharge are causing risk to the environment. We have never said this statement. Risk is actually a realization of hazard. So, we will compare this more interestingly in the coming modules and different lectures in detail what are the different methods, but let us try to understand globally. Hazard is more generic whereas risk is more specific. Hazard usually is qualitative, risk usually is quantitative, but there are qualitative risk methods also applicable to offshore industries. So, if I can apply my management policies and assessment tools even at the general level itself, I may prevent the scenario to get ripened or matured to become a risk. The moment it becomes a risk, it may land up in accidents and then the consequences are very severe, which can even bother the whole financial index of the industry as well as the country, even the global financial index. So, our idea whole here as an environmentalist in terms of offshore engineering perspective is how the general level problems which pose threat to the environment can be managed, can be assessed, can be diagnosed, can be controlled, can be prevented, can be regularized, so that at any given point of time they do not mature enough to become a risk. You understand the point? So, we are not saying that oil exploration production, oil and gas industry is actually a risky factor causing serious threat to the environment. We are saying the whole issue is likely to create a threat to the environment, therefore, they are hazards. So, in this lecture, we will talk about how to assess them very briefly. However, we are going to discuss hazard assessment tools in detail, coming modules in detail lectures with very good examples applicable to industries. But here we will talk about only the primitive methods of how hazards are actually assessed and managed, especially applicable to environmental management. We are not talking about any industry or any specific plant or any specific chemical, not intrinsically at this level. We will talk about that later. However, now we are planning how the hazard assessment and management can be applied to environmental management, which is one of the important tools in HSE. So, having said this, the hazard assessment and management procedure commonly used in oil and gas industry can be explained very well using a simple diagram, which is a flow chart. Let us say hazard assessment as applicable to oil and gas industries can be explained with the interesting flow chart here. First, let us try to see, is there a possibility that accident development scenario. Once an accident development scenario is possible, then we are going to go for release models. We have already seen continuous release, intermittent release, that is plume model, puff model, we have seen them. For dense gases, for vapor clouds, we have seen equations, we have seen charts and tables and empirical relationships. We can use them and use appropriate release models, and foremost issue comes here. The chemical what you are talking about is the chemical what we are talking about, or the material in general, is the chemical flammable or toxic, because we already seen the toxicity limits prescribed by various international regulatory agencies. There are different methods by which you can check the toxicity limit. So, let us check, is the chemical flammable or toxic. Now, there are two branches from here. Let us say they are toxic, let us say they are flammable. The moment they are flammable, we should go for fire modeling. To estimate the effect of this, we should also do explosion modeling, which we are going to discuss in detail in the successive module lectures. We are talking only about the overall management part here. We should also then do damage models, what we essentially call Probit models. So, all these are applicable to flammable chemicals. If it is non-flammable but toxic, then one should go for dispersion modeling. We have already seen the dispersion coefficients etc. in detail in the last few lectures. So, one should go for dispersion modeling. You have got to estimate the concentration, to estimate the concentration of the toxicity of the material. Then one can again go for damage modeling, which essentially is so in both cases, whether the chemical is flammable or toxic, in both cases we land up in a common assessment tool what we call as Probit model. So, in this lecture we will slightly elaborate this and see how a Probit model can be carried out and what are the constraints and factors which govern the Probit modeling tool. So, this layout or the flow chart clearly explains how an hazard assessment in terms of management perspective is to be carried out for an oil and gas industry if the scenario can ripen into an accident development, which is most possible, because in all our cases we have seen in oil and gas industries the explosion or the fire or the flammability is always a risky issue and it results in lot of oil spills, which is also considered to be an accident. So, these are all possible. In that cases we have to handle this in this manner. Now, let us try to see how an accident scenario can be developed further in detail. Okay. So, let us say development of accident scenario. The possibilities of accidental release of chemicals, this is true in case of processing industries which are related to oil and gas industries. So, we are located not offshore, but they are located onshore. So, they can result in BLAVE, boiling liquid vapor explosion, CVCE, jet fire, etc., which we will see in detail in the flammability models later. So, one has got to check whether the accident release of chemicals will lead to this kind of situation. So, one need to understand the operational data which can lead to the accident releases. What is the operational data? On the other hand, at what temperature, at what pressure, at what stability class, Pascal stability class, etc., the plant is operating, and what are the flammability characteristics, of the chemical, etc. So, these are all required to really know whether the accident release of chemicals can result in BLAVE, CVC, jet fire, pool fire, etc. Now, the question comes, once you know the accident release has happened, is the chemical flammable? Is it flammable? If it is yes, then one should talk about fire, which leads to fireball, flash fire, pool fire, etc. Then you can come back to the accident scenario, which will lead to the scenario. You can also directly come from this to the accident scenario. You can also connect this, or you can also connect this directly to come back to understand the accident scenario. Now, if it is no, then we ask a question, is it toxic? If it is yes, then one should understand the dispersion models. To understand this, we should also have an idea about non-operational parameters. What are the non-operational parameters? Climate, terrain, wind direction, etc. So, we should have a non-operational parameters which can also supply information to the dispersion model as well as to the accident scenarios as well. The moment I have fire which comes from a chemically flammable issue, then it can also result in combustion products. Now, these combustion products can also become toxic in nature. So, one has got to be clear. So, understand fire, again we have some non-operational parameters. Like chemical characteristics, ignition source, atmospheric condition, etc., which are necessary to really check whether it will result in a fireball or not. The moment I understand the dispersion parameters for a toxic chemical, then I can compute to the accident scenario. So, dear friends, once I have the accident scenario identified which can get from or ripen from an hazard scenario, then we come back to this argument again. This is where we were in the beginning, and that is how. So, these two can be tailed. On the other hand, the accident scenario can further lead to hazard management, which follows this flow chart, where the release models and you are talking about two, flammable and toxic, and then you keep on going. Ultimately, the hazard management tool ends up in estimating characteristics of the Probit model. So, now let us look at what is a Probit model. Probit model is a kind of damage estimate Generally, the Probit model gives the value in terms of probability units. So, it tells me from the following equation, the Probit function, what you see in equation 1, actually transforms a nonlinear dose response, nonlinear dose response into a linear relationship This is log dose and this is the Probit data, and of course, I can also explain this in percentage. So, it is actually converting the non-linear behavior into a linear behavior. That is what actually the Probit function is doing. Now, here interestingly you have to estimate y. So, y is given by k1 plus k2 natural logarithm of v, where k1 and k2 are constants. and V is the dose variable. The dose variable can be affected by various factors. What are those factors? The factors can be overpressure, it can be radiation, it can be impulse, it can be also due to concentration of dispersion, these are the factors which will contribute to the dose variable, which is an input for estimating Y. In a simplified form, the Probit value, which is actually Y, can be transformed to a percentage. Effect. So, this can be said the Probit value in terms of percentage will be equal to 51 plus Y minus phi of mod of Y minus phi error function of Y minus phi by root 2 equation 2, where ERF is what is called error function. Now, the Probit correlation for various damages which will help you to estimate the value of K1 and K2 constants are now seen on the screen. Please look at the screen for understanding the Probit correlations for various types of damages. One can see here the damage may be due to the burn deaths from fire, it may be lung hemorrhage, eardrum rupture, eardrum rupture, structural damage, glass breakage and so on, as you see in this table. Now, the dose variable is what is given in this column, and there are three kinds of possible hazards which can arise. It can be from fire, it can be from explosion, it can be also from toxic release and dispersion. For all these incidents, for all these categories, the Probit equation constants which are used to estimate the equation K1 and K2 are available here in the tabular form. So, one can easily find out these values directly for a specific kind of damage, for a kind of scenario, maybe fire, explosion or toxic release. If you look at this table, basically there are various variables shown in the table. Let us write down these variables and try to explain what are they. So, the indication of T is actually the time in seconds, I is the radiation intensity to find out the Probit constant, which is generally given in watts per square meter. P0 is actually the peak overpressure. Usually given in Newton per square meter. J is the impulse, usually given in Newton seconds square meter. C is the exposed concentration, usually given in parts per million, and of course, duration. As we explained, the other alternative hazard management essentially focus on fire and explosion, because these are very common scenario which can happen in oil gas industries. fire and explosion hazards. To understand the scenario which can arise from fire and explosion, one can use what is called Doe fire and explosion index, which is called FEI, fire and explosion index, which is very useful and a common method to study the fire and explosion releases that happen in oil and gas industries. Interesting data and authenticity of this particular method, which can be applied to oil and gas industries, can be seen from Papazoglou et al. 2003. Let us quickly see the flow chart to compute the FEI. That is fire explosion index. I request you to pay attention to the image shown on the screen now, which is showing me the flow chart to compute FEI. We have to select the application for a specific process unit. Then one can determine the material factor. Then calculate F1 and F2. One is for a general process hazard factor, other is called special process hazard factor. So, let us quickly list it here. So, the steps are very simple. Find the material factor which is responsible to cause fire and explosion. Second, work out constants F1 and F2. One is for general process hazard, other is for special process hazard factor. Please look at the screen now. Once you estimate both the factors F1 and F2, then get back to the process unit hazards, determine F and EI, that is nothing but fire and explosion index, which is nothing but F3 into the material factor, which you already got it here. Once you understand this, calculate the loss control. From the loss control, one can always determine what is called the MPPD, which we will discuss. From the F and EI, estimate the area of exposure, estimate the replacement value, estimate the base MPPD, and then arrive at the actual MPPD and check for the MPDO value, and then look for the base index. One can also determine the damage factor directly from the material factor itself. So, let us explain this slightly in a different manner. Step number 1, we will estimate the material factor. Let us say MF. Material factor depends on various parameters. One is the vapor pressure, other is the flammable or explosive characteristics of the material. So, based on this you estimate material factor. In step number 2, compute F1, which is the general process hazard factor. The general process order factor covers or addresses hazards such as reactions, material handling, etc. In step number 3, try to compute F2. F2 is a special process hazard factor which essentially comes from the special conditions that prevail at the site. In step number 4, compute what is called process unit hazard. So, this can be easy relation given by the equation one plus F1, 1 plus F2. Then compute the F and EI index, fire and explosion index, which is given by dou, which is simply the fire and explosion index is nothing but the product of PUH multiplied by the material factor. Once you know the fire explosion index computed by this procedure, then one can always say whether the process what you have been assessing is hazardous or not. It means we must then find out qualitatively the degree of hazardness associated to this whole example. So, dou has given a procedure and suggested a table. Depending upon what is the value of dou FEI you got, you can always claim the degree of hazards based on simple this number or this index. If the value what you get is between 1 to 60, one can say it is a light degree of hazard. If it is from 61 to 96, we can say it is moderate degree of hazard. If it is from 97 to 127, one can say it is intermediate degree of hazard. Qualitatively and comparatively, 128 to 158, we can say it is heavy, and more than 159 or more than 158, one can say it is severe. So, in a given process, if you are able to estimate the material factor and based upon the physical and special properties, identify the factors F1 and F2 and get the process unit hazard, where tables are available in chemical engineering handbook for various kinds of chemicals. One can easily find out the dou FEI. From the dou FEI, one can conclude very quickly what is the level or the degree of hazard this scenario is going to create to the environment. Is it going to be light or is it going to be severe? So, one can assess very quickly, one can try to plan or manage these kind of hazards depending upon whether you want to ignore it or you want to correct it. Now, the question comes, after assessing this hazard, we have to move to the management of this. So, the solutions to safety and injury hazards, health and illness hazards are generally implemented through rules and regulations. Interestingly, the awareness of this kind of hazard management came into play in the literature in the societal benefit only after the International Labour Conference in the 91st session held in 2003. After the International Labour Conference held in 2003, in the 91st session, the hazard management on environmental issues related to oil and gas industry became or gained high importance, which is conducted by US Department of Labor. Interestingly, the resolutions of this conference on this session advocates a very important parameter. It says that use systems approach to manage hazards arising from operational safety. So, what is the system approach? We will talk about this, explain in detail with salient examples applicable to oil and gas industries with certain process industries. But it was a very interesting resolution which was made from this specific session of this conference, based on which the hazard management or essentially hazard assessment on the environmental issues came into limelight, after which rules and regulations were formed and many countries started insisting these regulations very strictly on the stakeholders. In addition to this, people have also referred to various guidelines given by, there are other guidelines which are also useful in following or maintaining the environmental issues or environmental hazard level which arise essentially from oil and gas industries. One can look at the guidelines given by occupational safety and health management systems, which is ILO OSH, which is essentially a framework for occupational safety and health management systems advocated to oil and gas industries. According to this guideline, it is very interesting that the hazard management should contain the following. The hazard management program should contain the following: elements of policy, organizing the hazard management, planning and implementation, evaluation and action for improvement. So, they become the backbone of any hazard management schemes. So, what are the necessary or preferable outcomes of successful hazard management programs? The hazard management programs foremost should ensure operational safety, how this can be done? By mapping the business processes, by estimating hazards and risks, and then by recommending and implementing controls on all the three areas: upstream, midstream and downstream. That is the first goal or first desired outcome of any hazard management program. The second should be, it should enable workers to follow consistently the health and safety practices. The third outcome should be, it should help in managing site inspections or permits. Which essentially comes from the planning side. It should monitor for any violations, and it should also list best practices of safety. Most importantly, it should be well documented indicating both the strategies and planning, and it should be easily understood, that is very, very important, and made available to all workers for reference. This is a very important issue where the oil and gas industry stakeholders themselves are involved in policy making of hazard management. So, that is a very effective tool, and that is one of the desired outcome which is expected from a successful hazard management program. Alternatively, one can also go for health and safety plan. One can go for health and safety plan. This will include planning at administrative level, work area management, health and safety risk management, inventory management, etc. This plan has got again desired outcomes. 1. It ensures well-being of all the employees. And public in the society. It ensures environmental protection. It also accounts for workforce performance and rewards for efficient management. It should also lead to regular assessment routines. In terms of monitoring health and safety practices, both in leading and lagging zones. It also enables reduced cost associated with accidents. It gives a competitive edge in the commercial market and improves relationship with the between the stakeholders. It also has or addresses various methods that can control fire and explosion accidents, so it leads to various recommendations of fire and explosion proof equipments, fire fighting and control devices, fire indicators, alarms, sensors, etc. So, all this put integrally the management into a very successful result as far as hazard. There are various ways by which we can do this. There are varieties of software available to do this. The software could be safety, fast risk, risk spectrum, ASAP, Plateau, etc. So, interestingly, hazard management is actually a culture. It need to be practiced, it need to be trained, it cannot be educated. Process hazard analysis is of course a thorough, orderly, systematic approach which can be used for identifying, evaluating and controlling hazards in the process industry, which is one of the important application in oil and gas industries in the present scenario. Therefore, the employer must perform an initial process hazard analysis to ensure that the system does not create hazard to the environment. The process hazard analysis must be appropriate to the complexity of the process and must therefore identify, evaluate and control the hazards which it can pose to the environment back. So, the whole issue can be bracketed in one term called process safety management. It can protect the workforce, can protect the contractors, protect visitors to the plant, etc. The risk management programs, which are also derivative of these kind of hazard management programs, protects the community, protects the general public and the facility, and of course protects the facilities such as schools, hospitals nearby the process industries, which are all connected to offshore industry, which are located on shore. So, in this lecture we discussed about various tools that can be used for hazard management. Related to the environmental management, what we have been talking about essentially from the top oil and gas industries. Thank you very much.